Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving the greatest integer function, right? So here we have to evaluate this integral from -1 to 1, and here the integrand is e raised to x, and we have cos of y times the greatest integer of x plus 4 minus greatest integer of x plus 4, right? So here this symbol denotes the greatest integer function, and here also we have the greatest integer function, right? So in this lecture we'll see how we can solve these type of integrals and how we can simplify the expressions containing the greatest integer function, right? And in this problem we'll also make use of one important property of greatest integer function, right? So let us start, and let us first call this integral as I. So here the limits of integration are from -1 to 1, right? So the lower limit is -1, the upper one is 1, right? And here we have x plus 4 minus greatest integer of x plus 4, right? So let us make use of one important property of greatest integer function, which says that if we have greatest integer of, say, x plus p, then we can write this expression as the greatest integer of x plus p, right? So here we can isolate this p, and this p must be an integer, right? So here we have greatest integer of x plus 4. So here this is 4 is an integer, so p is 4, so we can write it as greatest integer of x plus 4, right? So now this integral can be written as -1 to 1 e raised to x cos pi, and here we have greatest integer and x plus 4 minus, here greatest integer of x plus 4 can be written as greatest integer of x plus 4, right? So now we have the value of greatest integer of x plus 4 as greatest integer of x plus 4. And here we have still one symbol for greatest integer function, right? So let us simplify it. So we have -1 to 1 e raised to x cos of pi, and here we have greatest integer of x plus 4, and now we can multiply these two numbers with -1, so we have minus greatest integer of x minus 4, right? And we can see that these two quantities get cancelled, and we are left with -1 to 1 e raised to x cos of pi, and we have greatest integer of x minus greatest integer of x, and here we have greatest integer symbol, right? Okay, so now see, here we have the limits from -1 to 1, right? So here the lower limit is -1, upper limit is 1, right? And between -1 and 1 we have the integer 0, right? So what we will do, we'll break this integral as a sum of two integrals. So the first one is from -1 to 0, the second one is from 0 to 1, right? So we can now write -1 to 1 e raised to x. Here we have cos pi, and here we have greatest integer of x minus greatest integer of x, and then we have the second integral. Here we have -1 to 0, right? And then we have 0 to 1, and here we have e raised to x cos pi, and here we have greatest integer of x minus x, and this is dx, right? Okay, now we have two integrals and we have to solve them separately, right? Now see, in the first integral the value of x, it lies between -1 and 0, right? So here we have greatest integer of x, right? So now see, when x lies between -1 and 0, then the greatest integer of x must be equal to -1, by the definition of greatest integer function, right? And see, in this integral we have the limits from 0 to 1, so x lies between 0 and 1, so the value of greatest integer of x should be equal to 0, right? So now here we'll take greatest integer of x as -1, and here we'll take 0. So now the integral reduces to -1 to 0. Here we have e raised to x cos pi, and here we have greatest integer of x plus 1, right? So here we have to be careful, because here greatest integer of x is -1, so minus and this minus becomes plus, so we have plus 1. And here we have 0 to 1 e raised to x cos pi, and here greatest integer of x is 0, right? So we have simply greatest integer of x here, because this is x minus 0, so that is simply x. So now we have these two integrals, and still in the integrand we have the greatest integer function, right? So now again apply this property or the definition of greatest integer function. So in the first integral, x lies between -1 and 0, right? And here we have greatest integer of x plus 1, right? Because we have to get rid of greatest integer of x plus 1, and here greatest integer of x. So in the first case, x lies between -1 and 0, so let us add 1 throughout this inequality. So here we have -1 plus 1, and here x plus 1, here we have 0 plus 1, right? So here we have 0, here we have x plus 1, and here we have 0 plus 1 is 1. So x plus 1 lies between 0 and 1, so the greatest integer of x plus 1 should be equal to 0, right? So here we have 0, right? And here x lies between 0 and 1, and here we have simply greatest integer of x, so this should be equal to 0, right? So now we have -1 to 0, and see, here we have e raised to x and cos of pi times 0, right? Because greatest integer of x plus 1 in this case is 0. And similarly here we have 0 to 1 and e raised to x cos of pi times 0, right? And here we have dx, here also we have dx. So now here we have I is equal to -1 to 0 e raised to x, and we have cos of pi times 0, that is cos 0 dx, and here we have minus 0 to 1 and e raised to x, and here we have again cos of 0 dx, right? And we know that cos of 0 is 1, so this is 1, this is also 1. So I is -1 to 0 e raised to x dx plus 0 to 1 e raised to x dx, right? So here we have 1, here we have 1, so we have simply e raised to x, e raised to x. So now we have two simple integrals. The integral of e raised to x dx is simply e raised to x, right? So in the first case we have e raised to x, limits are from -1 to 0. Here also we have e raised to x, limits are from 0 to 1, right? So we'll substitute the limits and we'll take the difference in both the terms. So we have e raised to 0 minus e raised to -1, and here we have e raised to 1 minus e raised to 0, and we know that e raised to 0 is 1, so we have 1 minus e raised to -1 plus e minus 1, right? So e is the exponential number, so we have 1 minus 1 over e plus e minus 1, so this is e minus 1 over e, right? So 1 and -1 get cancelled, right? So we have simply e square minus 1 over e, right? So viewers, the value of this integral is given by e square minus 1 over e, right? So this is how we can solve these type of integrals involving the greatest integer function and utilizing the various concepts from trigonometry, from algebra, and from functions.